Hello, AP Chemistry students, and welcome to Earth. I wonder where you are right now. I know that I am here, more specifically here, more specifically here. I hope you are all in the same spot and enjoying your AP Chemistry homework and my ability to look and sound like a complete moron. Moving on to the problem at hand, we are looking at exercise 12 on page 9. And as you can see here, I wrote out the equation again. If we have a half a mole of nitrogen gas mixed with 0.86 moles of oxygen gas in a 2-liter vessel, and I have the Kp, which is the equilibrium constant for pressure, at 4.1 times 10 to the negative fourth at 200 Kelvin. What are my equilibrium concentrations for all of the chemicals? So all chemicals being the nitrogen, the oxygen, and the nitrogen monoxide. If you just came from the previous problem, which was exercise 11 on page 9, we only solved for one concentration for a product, which is CLF. In this case, we want to solve for all. So we're going to have to plug into X, and it's not going to be much more difficult, but here we go. So the first step that we need to do in this problem is realize that I am not given molar concentrations. I am only given mole values. So in order to get to molarity, which is moles over liters, I just need to take my mole values and divide them by their liters. And the liter value that we're given is here. So pretty much you're just going to see that it's going to be 0.5 over 2 and get a value. But let's write that out so that we are certain. On the next page. So we have 0.50 moles of N2 divided by the 2.00 liter vessel that it's in. 0.5 divided by 2 is simply 1/4, or 0.25 molarity for N2. Similarly, we can do the same thing with oxygen, and we have 0.86 moles of oxygen over 2 liters, divided by 2 is 0.43 molar for O2. And so now that we have our capital M molar values, we can get moving into our Rice table. The next page will have this set up for us. Again, if you need time to go back over that, just press pause and rewind. So next page. Here I have my Rice table set up. Double lines for my equilibrium arrow, single line for my plus sign, and I have my Rice set up on the left. Now let's take the values that we just solved for and plug them into our ice. So initially we have 0.25 molar N2, which we just solved for, and for oxygen 0.43 molar. We are not told of any initial concentration for nitrogen monoxide, so that is going to be a 0. And the other thing is that we haven't been given any equilibrium values. In fact, we need to solve for all of these. If we recall back to our next steps, we want to next go to the C part, the change. And we know that any reactant is disappearing So anything on the left side of the arrows is disappearing, whereas anything on the right side of the arrows is appearing. So positive. We then want to look at the coefficients from our balanced equation. So if we look up at N2, that's just a 1. O2 is a 1, just like we've seen before. But in this case, we see that NO is a 2. This will change things slightly, but not too much. So for N2, we can say that because we don't know any other values, we don't know any values down here, and when we don't know that, we want to say x. So minus x, and in this case, because we have a coefficient of 2, we want to say plus 2x. So all these numbers are, this is a 1 here in front for the coefficients, 1, 1, 2, just from the balanced equation. Next we look at our E, knowing that I plus C equals E. And so we have 0.25 minus x, 0.43 minus x, and 0 plus 2x, or just 2x. Now that we have our information for our E, we move to the next step, which is to plug into our K formula. Next page. We know that, again, K is equal to concentration of products to a coefficient over concentration of reactants to a coefficient, and this is equal to a value. And in this case, our K is equal to 4.1 times 10 to the negative 4th. Taking our values from the previous page, just going to plug those in. So my product is the NO, which is the 2x, and so I'm going to place that on the top. And so this is going to now say that K is equal to the concentration of NO raised to a coefficient which is 2 over my my equilibrium concentration raised to their coefficients, which are just 1 and 1. It is vitally important that you remember to square this value here. It is the first time we've had to do it, but it is vitally important that we square it. So let's plug in some values that we had from the previous page. And on the top we have 2x squared over 0.25 minus x and 0.43 minus x. And that's equal to your K value, which is this value up here. But just like we did in the last problem, when our K value has a small enough exponent, we can get rid of the minus x and the minus x here. We do not get rid of this one because we need to solve for x. And so that's the x that we're going to solve for. So rewritten, this now looks like our K, which is equal to 4.1 times 10 to the negative 4th equals 2x, the quantity, squared. Know that you need to square both the 2 and the x. And so this becomes 4x squared, because 2 squared times x squared is 4x squared. Divided by 0.25 times the quantity of 0.43. Now that we have that, we can solve for x. It takes a little bit of algebra. To get anything off of the bottom, we need to multiply across. And so I'm going to move on to the next page with this. And so I should have 4.1 times 10 to the negative 4th times 0.25 times 0.43 equals 4x squared. This value on the left here, well, that was bad, but that value there is equal to 4.4 times 10 to the negative 5th equals 4x squared. Dividing both sides by 4. Mental math here I hope you can do. 1.1 times 10 to the negative 5th equals x squared. Take the square root of both sides. Therefore, x equals the square root of 1.1 times 10 to the negative 5th, and x equals 3.3 times 10 to the negative 3rd molar. But again, we need to plug this x value back in to our Rice table, because this is not any certain value. Notice here again that this is my x, x, and x. So I need to plug that x back in, and so we will do that here. So my e, if I want to rewrite this here, for each of these was 0.25 minus x, 0.43 minus x, and 2x, where my x that I just solved for was 3.3 times 10 to the negative 3rd. Or if we want to write this out, that's going to be 0.0033. Because 1, 2, 3 spots gives me 3.3 times 10 to the negative 3rd. I then need to plug in my value. So I have my N2, I have my O2, and I have my NO. Plug in x. And so we can see that N2 initially was 0.25 minus this 0.0033, 0.43 minus 0.0033, and 2x, which is going to be 2 times 0.0033. And we can get some values. The N2 and the O2, this 0.0033 is very negligible. So when we look at the sig fig values, it would be 0.2533, which doesn't have much of an effect on the answer. Same thing with this one, 0.4333, no effect. So we can just say that this would equal 0.25 molar, 0.43 molar, and then this one on the bottom, we do get a value of 6.6 times 10 to the negative third, or 0.0066 molar. And so to finally wrap this up, we can make one more page and say that my N2 concentration at equilibrium is 0.25 molar. Equilibrium concentration of O2 is 0.43 molar. My equilibrium concentration of NO is 6.6 times 10 to the negative third molar. This problem is very similar to exercise 11. The only thing that changed in this problem, which is very important, by the way, is this 2 from the coefficient. This change in the 2 from 1 to 1 to 1 ratio to 1 to 1 to 2 means that we now have a coefficient that squares and becomes our exponent. This mandates that we have this x squared and even this 4x squared value. And so our algebra is a little bit more complicated, but not much. Take the square root value here, solving for x, plugging the x's back into your e values from your rice table, and we get final values for our equilibrium concentrations of certain species in this equation. Please email me if you have any questions or need any help. I look forward to seeing you soon. Thanks again.